Hello learners, we are going to talk about actuator. The actuator converts the source of energy into physical mechanical motion. That source of energy can be in three different forms: pneumatic, electric and hydraulic. They receive inputs and transform this input into mechanical motion to perform a specific task. In very simple terms, an actuator is a device that makes something move or operate. Every one of us take advantage of at least one actuator every day. When we go to the grocery store, the door opens automatically for us. An actuator makes the door open. We can move the car seat forward or backward before we drive away in our car. An actuator makes the seat move. Do you know the different type of actuator exist? Electric actuator, pneumatic actuator, hydraulic actuator and thermal actuator. First talk about the electric actuator. These actuators use electricity to generate mechanical motion. They can be further categorized into DC servo motors, AC servo motors, stepper motor and linear actuator. Pneumatic actuator use compressed air or gas to generate mechanical motion. They are reliable and widely used in industrial automation and control systems. Examples: pneumatic cylinders, pneumatic valves. Hydraulic actuator use fluid, usually oil, to generate mechanical motion. They offer high force capability and are commonly used in heavy duty applications. Thermal actuator utilize temperature changes to generate the motion. Let's talk about moving ahead towards the actuator role in IoT. Integration of sensor and actuator allow the real-time monitoring, intelligent decision making and precise control of physical processes, making them integral component in various applications including industrial automation, robotics, smart building, automotive systems and IoT-enabled devices. First step is the sensing. In sensing, sensors are devices that detect and measure specific physical parameters such as temperature, pressure, light intensity, proximity, motion, or chemical composition through various sensors. They convert these physical signals into electrical signals that can be processed by the systems. Next one is the signal. Once a sensor detects a physical parameter, it generates an electrical signal that represents the measured value. The signal is then acquired by the system, typically through an analog to digital converter, which converts the analog signal from the sensor into a digital format that can be understood or processed by a control system. Control system that acquires signal data is processed by the control system, which may involve algorithm or logic. The system analyzes the signal data, compare it to the predefined threshold or condition, and makes decision or generate control signal based on this information. The control system determines the desired response or action based on the sensor inputs. Fourth one is actuation. The control system generates control signals or command based on the process sensor data. These signals are then sent to the actuator, instructing them to perform a specific action or movement. Actuator receive the control signal and convert them into the mechanical, electrical, hydraulic or pneumatic forces to execute the desired action. Last one is the feedback loop. After the actuator perform the required action, they provide feedback to the control system, allowing it to verify whether the desired action was successfully executed or if adjustments are necessary.